Hello guys, Dharmendra Soni here, and you are watching my YouTube channel. And today we are going to learn about Docker in full depth with beginner-friendly guides. We are going to talk about a lot of problems, a of uh, lot of things about Docker, like what is the problem statement, why Docker is important or not, um, why how to install the Docker on your and on any kind of platform, what are the images and containers, what is the registry, what is um, uh, Ubuntu Mage, how to start Ubuntu Mage, how to run multiple containers, how to do the port mapping, environment variables, Dockerization with, and I'm also going to create a basic Node.js server and talk about and Dockerize it and show you how to start it. And also I'm going to talk about one amazing functionality about Docker Compose. So let's begin. So yeah, so what is a Docker? So and why it is very important. So let's talk about this. And let's say you are a software engineer and you are working on a project. Let's say this is a project. This is a basic e-commerce application. E-commerce application. And in this application, you have, let's say, about um, you are running Node.js as a backend, Next.js as a front end, okay, with SSR, Postgres as a database, and Redis as a in memory cache. Okay, so this is the application. This is the whole thing. This is the plugins required for this e-commerce application to run. And let's say you are alone working on this project, and you are working on this project, and let's say you have and you want to fast track this development experience. So you did is that you hire another developer, and or your company hired another developer and he start working on this. Okay, so you both are going to have the same thing, uh, same installation. Let's say for some reasons you have decided to your Node.js the Node.js application, Node.js version on your system is 18. Okay, and Next.js is let's say 13, Postgres is let's say 14, and Redis is around let's say 7.2. Okay, and for some reason, and he has, and the other programmer has, he or she has 20, Next.js is installed 10, Postgres is installed 12, and Redis is around 5. Okay, so what you did in this scenario is that since you are more experienced in this project, so you are going to talk and you shared the code with him. He started the application, and some reason the application is not able to restart due to like the lack of node and the compatibility and all. So what you did, you both guys come on a call and decided to upgrade or downgrade the versions with each other. Okay, and let's say, but you are also using Mac, okay, but he or she is on Windows. And for some reasons, what happens is that you have installed some kind of plugin on your Mac that is only available on Mac devices. And since he or she has Windows machine, she or he cannot have that application. For example, as far as I know, there are some applications. Let's say you are building you are adding a feature, let's say image crop feature, and you for that you are using ffmpeg. Okay, and ffmpeg, there are some binaries who are only available on Mac, and and that binary is not available for Windows. What happen is that what will happen is that either this developer have to move to the Mac, okay, and destroy his Windows machine, okay, and this cannot be happen again and again and again. So let's say in the big projects, let's say you there are 20 developers, and you cannot say all the 20 developers or more than 20 developers that use this configuration. So what you need is that you need some kind of system that does this in a container way. And what is the best ways to do is that uh, you need uh, you need a system, you need a in a way that images can be copied. You need a way to hand over that that all configuration, and in one click it can be started. So let's say, what if there is some kind of way that I can say that, hey, take this image, click this, run this command, and your whole application will start. This way, this whole thing will be separated, and no matter how many developers are coming and going, your environment will be consistent, and all the developers can work without any hesitation. So, to solve this problem, this is called sandbox environment or virtualized environment, or there are, I don't remember that specific word, but that is called um, container environment. Container meaning that, so let's say talk about container. What is a container and what is this called? I really forgot that word. So this is, let's say you have a Mac OS machine, or you have a very good hardware. So what that hardware will have consist of, it will consist of some kind of GPU, CPU, RAM, and memory. Okay, this is the hardware. Okay, and on this hardware you can install any kind of software. Software meaning is that you can install Windows, Windows, Mac, or Linux, and you can just take this image and run it on this machine. So this machine will call container, and this will call image. So this is, and what if there is a way to just containerize it, take it into a zip file. Let's say we containerize it and zip it, like compress it, and share it with anyone who wants it, who is working on it. So to do this, we have a very amazing tool called Docker. So Docker solves this problem. So yeah, and throughout the videos, we are going to talk about that. So let's begin. For that, we need to, first of all, we need to install the Docker on our machine, and to install the Docker, we need to go on this website. Okay, and you can just click on this, and you will have all the important images. You have all the you can just click on this link, and it will get installed. And for me, I have already installed that, and we do not need to do that. So for that reason, we are not going to complete this step. And let's begin to the next step. For the next step, we are going to start the Docker. Let's start it. To start this Docker, okay, I have started this, and you can see I have few images, but yeah. And to start this, we have this, and let's begin to our next chapter. So the next chapter is let's. I have already talked about this. What is Docker? What is image and containers are? But let's talk in depth again. Let's talk about this again. So let's say uh, you have a machine. Okay, you have a. Right now, I am using Mac OS. Let me take a zoom. Let me do a zoom here. Right now, I am using Mac OS. So on the Mac OS, I have around 16 GB of RAM. Okay, and 256 GB of memory, and I have one M1 chip. Okay, and it has pre-installed uh, iOS installed. iOS, I think it's Darwin. Yeah, Darwin software is already installed, pre-installed it on my system. Okay, this is so what we will call this. This is a container. This is a actual machine, and this is a image. So image you can think of like any kind of software, whether it's Linux, iOS, Windows. This is will called image, and image have a lot of pre-installed software like Power, like you can think of like your there are a lot of applications like settings software. There are a lot of pre-installed, pre-configured software comes within it, and yeah, that's all. And what and yeah, and this will call this is the image. So I think you got a pretty much idea what it is. If you're not, please write me in the chat box, and we can also we can talk deep dive into it. The image, and this is will called Linux, uh, iOS, and Windows. Okay. We just take this and install it into this, and this is called containerized environment. Okay. And what if so? What if I'm working on a software and that required this kind of configuration? That require this configuration. I can just create a custom image from this and containerized it and share it with anyone. So let's I can and install it on my Windows along with iOS, and it will run smoothly. This is called very specific. This is called containerized environment. Okay, and let's go next. Then what is a Docker registry? Let's talk about the Docker registry as well. For the Docker registry, what is the Docker registry? Why we need it? So for the Docker registry, you can think of it like a central repository that have a lot of images images, public and private images, and you can download it from the internet and run it. So you can compare Docker repository as your kirana store, or and for the US, you can think of it like a mall. In a mall, if you enter in a mall, there are a lot of shops who sells different kind of goods, and you just go there. You just take something and pay the bill, and you take it out, and this is how it is. And if you are much more experienced in the software engineering, think of it as like GitHub repository as well, or Git repository. So we have Docker provides a central repository as well. Of course, you can create your own repository servers and for the individual organization. But for sake of these videos, we are going to talk about central repository, the default repository provided by Docker called hub.docker. Okay. Docker Hub has a lot of different pre-built um, repository images, okay, like Ubuntu, Postgres, HTTPD, Mongo, Warp, Docker, Docker Soros, PHP dumper. These are the pre-images that you can just click on this image and start it. So let's install this Ubuntu image. So for this we are going to go into the terminal, okay, and pull the image. So Docker pull Ubuntu. So let me give you one more thing. So whatever whatever image you will pull, it has built for certain kind of architecture. Okay. For my video, I am using ARM device, so there is ARM build as well. But if you are AMD, then you need. So be of course you can run ARM on AMD and AMD on ARM, but it is going to slow. It will going to take a lot of. It is going to take and consume a lot of CPU and memory. So for this, always if you are going to download any kind of images from a central repository, always go to the Docker Hub and see if that architecture, the OS that you are using has the image has same architecture as your hardware. Okay, so we have already installed it, and let's start the image. So for this, I'm going to Docker it Docker run, yeah, Docker. I'm going to say I am going to say like Docker run in interactive way Ubuntu, and yeah, I am in the Ubuntu image, and here I can do whatever I want to do, and no effect will be happen on my system. So let's see what I am trying to say here. So meaning is that I hope you get the example correct. So let's say this is my image, okay, this is my host machine, okay, on that host machine I am running a container. uh, I'm running a container, and this container is completely isolated from this environment, from this environment. So whatever I will do, I will perform, I will install any kind of virus, and if I install any kind of if I do any kind of harmful way, no impact will be happen on my machine. So on my actual machine. So I am completely safe. Whatever I will do, I can do it. I can do a lot of things and no impact. So uh, so this thing enables, and this opens a door for a lot of experiments. So if you are very good at experimenting, you can always use Docker to experiment your task. Okay, so yeah, this is it. This boots up a complete isolated environment, and that we can do. So let me give you an example. So um, let me open a PWD, and I am at the root. Okay, and let me open this as well. This is my host. This is the host, and this is Ubuntu. Okay, so if I do who am I, it's going to say root, and if I say who am I, it is going to say Dharmendra. Uh, if I say host name, this is 373, and if I say host name, this is going to say this. So whatever I will do, let's say I remove USR file. So RM, I don't know, I never done this, but let's do that. I completely remove the USR file. This is one of the important files that anyone can have. And let's go to this. I have the USR file. Yeah. So whatever things I will perform here, no impact is going to happen on this section. So I am completely safe. I am completely okay. I am completely uh, safe that nothing is going to happen. Also, let's take a look into Docker desktop. On this image, I have Ubuntu one image, and I am running one container. Let's boot up another container. So this also enables a room for I can boot up as many as containers as I want from one image. Meaning that, let's say I have one image. Okay, let's call Ubuntu. I have a Ubuntu image. Ubuntu. And I want to start one container from it. I want to start a container that in this container I am going to run a Node.js server. I can do that. I can just, if I want to start in this container, I want to start let's say a microservice for payment gateways. Okay, and in this microservice I'm going to start microservice for trans logging. I can do that. I can just take this image and start as many as containers as I can do, as long as my memory and view can support it. So let me, I don't know how to do this, but okay. Okay. This is it. And what I can do, I can just isolate this environment and create new images as well. I can create new images. So let's go for this. I can create new images called Node.js monolithic. Okay, I can say, and I can say it like Node is monolithic. And I can do the same for this disease and push it to the Docker registry, and anyone can start it from there. So yeah, so I can just let's assume it like you let's say you want to make a painting, and for that painting you go to the market. For this instance, and you take pen, pencil, color, uh, and some paper, and you take all those things, you create a painting, a wonderful painting, and you and when you finish the painting, what you do what you do, you just go to the market and publish it. If you want to publish it, you publish it, and anyone can continue from that point of view. So I don't know if this painting example is very relevant or not, but yeah, this is one analogy I can give you. So for this instance, let's go back and in the technical terms, let's say you want to create an open source project, let's say open source e-commerce. Okay. And for that open source e-commerce, what you do is that you write a program, and you write a program and you publish the code to the GitHub repository. And what you do, you also create an image with isolated environment and push it to and share it with anyone. Okay, and anyone who is going to work on your project, open source project, who can just take your image, take your code, and start working on from there. So he or she do not need to install all the libraries that uh, he or she do not have to suffer a lot to start working on a project. Do not need a pre-configured environment. They can run it. They do not have to switch to any specific kind of a machine. Let's say, for example, if the user is on Windows, they can run the containers. If they are and you are on Macs, they do not need to switch to Mac to work on a project. They can just go to their system, install the Docker, and start working on from there. So yeah, this is very great example that I can give you. If it not make clear, please let me know. If you have any questions and doubts, or you can always ask me. Okay. Yeah. Where I was on the Docker repository. So on the Docker repository, you can create these, and you can push and pull. So let me give you an example. So as well, I will give you an example by the end of the video. Okay. Please stay tuned. Uh, so let's move on to the next step. So how to run an image on your local. To run an image, you need to pull the image. cd. I have already done that. Docker pull. Okay. I have pulled the image here. And if I want to start a container, there are many ways to do it. There is an interactive way, there is a daemon mode. Okay. There are two ways to do it. So interactive way meaning that you are interacting with the shell, meaning that you are booting up. Um, Also, let me go to the my example. So meaning that, let me take here. Let me come back to here. Meaning that you are what if you are let's say this is your machine. Okay, this is your machine, and you are interacting with it. To interact this with, you have many ways to do. Like there are many input devices that you can offer. The one input devices like keyboard, mouse, monitor. These are the interactive way to communicate with this machine. I can plug in a keyboard to write type. I can plug in a mouse to move things around. I can plug in uh, camera to record myself. I can plug in a audio system to record my voice. So there are many ways to interact with it. To interact with a Docker container that has started on your system, you can still use those things. You can use your mic. So your host interactive system is going to be reused in your this isolated environment. So it's called Docker container. Okay. You can uh, you can type it here. How you are going to type? You are going to, let's say, let's create a keyboard. This is a keyboard. Mouse, monitor. Okay. What you do is that you just plug in here. You plug on. You plug in your keyboard. You plug in your mouse. You plug in your monitor to your host machine. This is called host machine, and this is called host image. Okay. And what to interact with this Docker container, because this is an isolated environment, you need to, there is a command called it. So let's say I am running an image, Docker run. To start it in an interactive mode, do just do it like it and Ubuntu. It is going to create a new container. It is not going to start an old container. It is going to start a new container, spin up a new container, and what it's going to take, and it is going to interact with it. To interact with it, one of the most common way to interact with it is shell. So this image shell, the default shell is bash. So let's So this is a default shell. Default. So it is going to take this Ubuntu image shell and attach it to this thing, and I can interact with it. I can give it a commands like ls, rm, rf, mkdir. So I can interact with it to perform any certain task. What if I have to start an old container? To start up a new old container that you have already installed, to prove my point, let's start a fresh container. I have started a fresh container, and I'm going to start it like I'm going to write. I'm going to create a um, new folder, mkdir folder 1. Okay. I have one container. Okay. And this is going to, let's create a new container. Okay. Docker run it ubuntu. So we're going to start a new container. And you can see in this new container, I do not have this folder. Also, you can see the host name is different. This is 7 is CDD and this is 4B is CCD. Also, you can see it has two new containers, and these two containers are isolated with each other as well, meaning that whatever I will perform here, nothing will be going to touch here. Nothing is going to touch here. So yeah, and I can I can create many containers as well. Okay, so this is it. To see all the images, you can go to this Docker desktop and see the images. I prefer the old way. Like there are a lot of commands that I use in my daily life to do the. I mostly never use Docker desktop to be honestly speaking. So there are a lot of, and there this is because I feel like interacting with shell is more fast way than interacting with GUI. So the fastest way that you can see all the images is called images. You can see I have these images. To see all the Docker containers, you can see I have one container that is running. This is going to see all the containers that is going to this is running. Okay, let's exit from this container. Okay, what if I have to start the same container here? I do not want to start an old container. I want to start a new container. I don't want to start a new container. I want to interact with my old containers. To do this, you can use the following command: uh, docker exec. Exec meaning that execute. It meaning that interactive way, and the ID of it. You can come here and copy the ID. Let's say this was the image. So and yeah. Let me I think I'm copying it in the wrong way. me copy it. Docker sometimes recording times this is going to happen. let's let's figure it out. So let's see how you can execute, you can enter an old stopped container. So to see all the stopped container and all the running container, you need to run a command called docker ps a. Okay, you can see this is the command, and these are the all status has been exited, meaning that they are stopped right now. To exit, to enter into an old container, first of all you need to start the container. Docker uh, start. I have started the container, and then you can do like, then you can exit, then you can execute, then you can enter into the command, into the container. So right now, yeah, be aware that this is written, I think this is important, because this is the program that is going to run it into it. This is not an entry point, this is a command, meaning that it is going to run this image. After running this image, this is going to this position and run this, and after running it, it is going to start the shell, and that shell is, after running the shell, it is going to attach this shell into our own, into our host, and that way we can interact it with it. And let me show you, and here you have all the status. So yeah, this is one way. uh, if you want to learn more depth into the depth about it, let me know. I will also create a video about this. But yeah, this is the basic commands that you can use, that I use in my daily to daily basis, on my daily to daily basis. So yeah, that's all. And yeah, you can see I have already shown you this, so I am not going to show you. Yeah, then now what we are going to do is like, let's move on to creating a project, because I can show you the better way. So if I go to my personal, '24, let's create a sample basic Node.js application. To run a Node.js application, what I'm going to do is like, uh, okay, npm install express. After installing the express, let's run a main.js file const. Let's give it a port. Okay, and after giving it a port, let's assume that this is the port. Let's give it a host name. Remember, in the new Node.js library, the second argument is most important, and this second argument defines that what host name this is going to run, and for the container, it should be always global. It's best practice to have it always global in some environments. Console.log. Yes. Yeah. Okay. Let's also create a Docker file as well. Let's say, and let's Dockerize it as well. To Dockerize, first of all, we are going to create a Docker ignore. Why Docker ignore? Because just like Git ignore, that that help us to define what files and folders should be pushed to a repository. This Docker ignores does the same. This defines what are the folders and files should not be included into our image or Docker container, into an image, and then move on to the Docker container. So we do not want to send our node modules. Okay, this is all it. And let's create a Docker file. To name, you can name it as it is. Like you can name it whatever you want to do. You can write it at docker.file, docker.file. You can write, this can be anything, but the default Docker file is this. Like the default configuration sees that if you write it like like with Docker file with capital D without extension, this is the default name and you can use it. For this we are going to install the Alpine, because no, let's stick it to the Ubuntu. Let's see if we have the Ubuntu image or not. First of all, because this is a node project, I want to be as light as possible. So the lightest image I can find is like slim. But yeah, let's see what are these. So the best you can find is Alpine. Alpine with like I am using ARM, so it is going to be 45, around 45 MBs. And yeah, we are going to define the work dir. Work dir meaning that what folder. So every image is going to be has its own folder structure. and we want to work in a folder. To work in a folder, we need to define a work dir where I want to work. This is the step, this is another step. So we want to work in the F directory. If it is going to check out with the FD directory if it's present. If not present, it is going to create the app directory. Then we are going to copy all of our package asterisk .json to this app directory. Then we are going to run the npm install. Then we are going to copy our let's have the best folder structure. Let's move on to the source and move this here and write a script. Let's write a script called start with node src main.h, okay, and copy the source directory to this directory. And then what the entry point is always going to be in the node, so there is no problem with that. And then we are going to run this npm run start. So whenever someone is going to start this container, the default command which is going to run is this npm run start. Let's build it, and after building it, let's run it as well. So let's call it YT. So let's define it what it does. So it's going to run the docker command, and the second argument defines what action does it have to perform. The action is going to be perform the build action, and what directory is going to perform in the this dot, meaning that it is going to perform in this directory. You can either replace it with pwd or dot. They both perform the same, and this is the name. What are the name? If you do not provide it a name, it is going to take a default name, but yeah, best to provide a name that it can do it. So let's build it. After building it, it is going to look up on our local system, local images, and see if I have this LTS node LTS alpine 3.19 image present or not. If there is no image has been present, then it's going to look up into my default repositories, all my repositories, and it is going to check out there, and whenever it is going to find that image, it is going to download that and build an image. And yeah, we have this. The image has been built. Let me go there. Let me so docker images, and now you can see I have two images. One image was created 3 weeks ago by Ubuntu managers, and one image is created by me 41 seconds ago, and this is my image, and you can see this. So let's let's start this. To start this, I'm going to run docker run, and I'm going to take the repositories, okay, and yeah, it is going to throw an error. Why it is going to throw an error? Because it cannot find app source main.js. Let's investigate this. To investigate this, we are going to run it into interactive mode, IT, and YT test, and it is going to throw an error. So let's run this bin.sh, and this is saying that source folder do not present, and the file is moved on to this. So yeah, let's put this, and let's put this and exit it, and let's build again. We are building the image again, and let me give you a brief example what happened here. So what happened here is that you saw that this image, to build this image, it took around 3 minutes. So we started it on 12:49 and ended at 12:51, meaning that it took around 3 minutes. But for this, it only took around 10 seconds. Why? The question arrives here is that, is my build is correct, okay or not? So yeah, it is okay. It's totally okay. So what happened here is that, first of all, I did not have this Node LTS Alpine 3.19 image on my local machine. Okay, so what it took is that it downloaded that image and it took several seconds. It took around exactly 19 seconds, and then it performed all these steps. To perform all these steps, it took around 1 minute 5 seconds. And to sum up of all this, uh, uh, it completed it within 3 minutes. But here, the majority of the tasks were already been performed, meaning that I have already have an image, so it skipped that. Uh, if I have, uh, I did not. These steps were already been done, so it also skipped that. You can see the cached, like it. I have 5 steps. First one was completed. The second was also completed, and it was not touched. The third was, and the fifth one was not. This was touched. So it only performed this task. Okay, and yeah, that took it around 0 seconds. But yeah, so yeah, you can see why it was failed. So it is very friendly and it has a lot of caching. So this is very fast as well. So let's run this. So I have around now I have 3 images. To run the image, docker run, I need to run this, and yeah, I'm running it on for 3000 as well. What if I want to? So let me show you how it is running. So what happened is that, let's take this example further. Uh, So so I have this container. This is the host. On that host, I am running a container. Okay. So as I said earlier, this container has its own isolated environment. So nothing has been touched. Meaning that if I run a server here, no, I cannot interact with this. I cannot interact here. I can only interact here. But this is an isolated platform. What I'm going to do? I'm going to map it. I'm going to do something called port mapping, meaning that I know the internal container port is 3000 and I want to interact here. So what I'm going to do is that I'm going to run a command while running it. To run a command, I am going to going to run this command docker run -p 3000 3000 and then the image name. Okay, and this is going to expose this 3000 port on my host 3000 host, meaning that host 3000. So when I am interacting, when I will go into my browser and type 3000. Right now let's type 3000 localhost 3000. Wow, I am already running a server. Okay, um, let's change this to something else. Let me kill it. Yeah, now it has been killed. So let me start the container. Uh, Let me restart it on any other platform by passing an environment variable. And also let's go to the one step back and talk about environment variables as well. So what are the environment variables? So whenever you are going to whenever you are going to run a container, it has its own environment variables that are specific to that machine. So let me show you my example. This is my host. This is my host machine, and on this machine I have this many environment variables. And these environment variables define where are my paths, are what is the default shell that I'm going to use, what uh, folder I am currently in, what is open API key is what is this, what is that, and to run this, what I'm going to do is uh, I'm going to, when I will run a container, I will just I will just pass an environment variable, and this environment variable will be assigned at the boot time in this container. And whenever someone is reading an environment variable, it is going to read that value. So let me give you an example. So for this, as you can see in my current example, I am checking if I have in my system environment variable, if I have a port, okay, then take the environment variable port, otherwise the default port is 3000. Let's change it. So I have Docker images. I have this image and Docker run a port 3005 and call it, and now I am running this on port 3005. This is example, so I can inject the environment variable from my system and run it anywhere. Yeah, and this is it. And I did not, let me stop this again. Let me go to the dashboard and I'm going to recreate it. Let me, because I forgot to create a default port, so let me create app.all request and response. Let me rebuild, let me clear all these containers. Let me delete except, let me delete all these images. Okay, and let me delete all the volumes. I don't have to have any volumes. Let me rebuild again. Docker build. It's going to build the container. After building the container, it is going to, we are going to start it. So Docker run we are going to start it on. So if I start on my 3000 port, and if I go to this and if I write 3000, it is going to see that there is no port available on, there is no localhost connection with port 3005, but I am running a connection here on port 3005. How it is not being exposed? So to expose it, we are on this Node.js container, and this is 3005 port is running on this environment, in this isolated environment, and but I am sitting here. If I want to run this, I need some way to communicate from this to this. So to interact with this, we have IT mode, like to interact interactive way, but we need some way to forward. Like whenever I'm talking on 3000 port, 3005 port here, I will be communicating to this port. So to do this, I need some way to do this. 3005, 3005. Let's exit from this container and start a port forwarding. Uh, Let me stop it. So docker run minus p 2005, and to prove my point, the internal port is going to be 3000 as well. I'm not going to check 3000, and then I'm going to say so I'm running on 3005 port, but I can interact on my 3000. I'm run the container is going to run on the 3000 port, but I'm going to interact with this on 3005 port. You can see here, this application is running on 3005, but actually I'm running on 3000. This is called interactive way. So to understand this point, you need to let me give an example. Uh, it's a very funny analogy. So in a corporate, let's say your manager is asking to do something. What he's going to do there, he's going to ask a subordinate or assistant manager to tell you to do this. So that communication is forwarded to you. Okay, so this is meaning that your manager is communicating uh, with his subordinate, and that subordinate is communicating with you, and then you are answering to your to manager's subordinate, and manager's subordinate is answering to the manager. There is no actual communication happening between you and the manager. Okay, it is happening through a subordinate. Okay, you can so I think so. Yeah, this is the correct analogy, and yeah, this is you can understand how it is going to take this, and yeah. So there is one question arises: isn't it slow? For the computer sense, no, it's not slow because this is happening in on the host. This is happening on my common layer. So the latency is very minute that can be ignorable. Okay, so this is not going to halt any kind of performance issues and all. So yeah, this is you can understand as well. And yeah, so this is my example. So another question arrives is that is there any way that I can, because every time I'm running a certain things, because on a daily basis you need to check in, check out, run, start, stop, a lot of things here. Is there any way that I can define a configuration, and that configuration is started and stopped on a single command? And the answer is yes. There is one way to do it. To do this, we have Docker comes with Docker Compose file. Docker Compose is Docker Compose is a way that to interact with a compose file. So in the name itself, you can see it's a configuration file written in YML, and that YML have a lot of composition of configuration, a lot of services. In that composition file, you can define networks, you can define services, you can define volumes, okay? And with that volumes, you can um, you can start, stop, create, and all that, and you can do it in a single command. Let's also perform this. To write a Docker Compose file, you need to define something called Docker Compose dot y YAML. I do not understand why it's YML and YAML. But yeah. So now we are going to define something called version, and the version is going to be like 3 dot abstract, and we are going to define our services. Uh, there is another tag called services, and in that services I'm going to give it a name. The name is node backend, and that we are and now I am going to define the build. To build it, I need to find the build is going to be this. Port is going to 2005 to 3000, and yeah, you can also define volumes like volumes. This is a very interesting concept. Uh, Let me also talk about the volumes. So, meaning that uh, this is your isolated environment. This is your isolated containers, and this isolated containers has everything. Like it has host machine, host network. It has can have host RAM. It has host CPU, but it does not have a persistent memory, because let's say you are saving some in your application. You need to run a database. To run a database, you need a persistent memory, and to run the persistent memory, you need to have some way to save it, because once your container is deleted, your data is also going to delete it. So there are two ways to have volumes. One is to have a shared volumes, and one is have a named volume. A named volume meaning that it says that uh, you just create volumes and provide a name, and the name is going to be like, let's say, backend per, and yeah, and that's all. And now you are going to say it like from volume persistent at whatever you will do, you just bind it to app.src. So whatever changes is going to happen here, it is going to save a copy here as well. And yeah, and this is going to, if this container is deleted somehow, this is going to be saved as well. But what if I do not want a named volume? I want to change the file here, and this changes are going to be reflected on the real time here. You can also do that as well. To do that, you are going to just define src, and whatever changes are going to happen here, it is also going to reflect here in a read and write. So this has two mode. One is read only and read as, and it has read and write as well. Let me prove my point. Let me give you an example. So let's say let me see if this is correct command or npm run start. Yeah. So whatever changes I'm going to happen to here, it is going to be reflected in the container as well. Okay, so let's get started. First of all, let's go back to a point and start the Docker compose. To start Docker compose, you just need to write Docker compose up, and this is saying that okay. Uh, okay, and now the changes has been reflected. What is going to happen is that let's change it. Express server is running code in Docker, and you can see my changes are reflected here. This is happening in real time. So if I remove this container here, nothing is going to be deleted here. This has persistent memory, and yeah, this is called persistent volumes. Now, and this Docker Compose, what it does is like, if you let's open my another terminal. Okay, and Docker PS. So you can see that, don't say this is the correct. I can show you. So you can see this is the Docker container. In this Docker container, I am running this image. This has this tag, and I have defined this thing. And you can show the details. You can see this thing. You can define the exits. You can bind the mounts. Okay, so my volumes are mounted. My Docker, my Docker is mounted to this to the container. This volumes as well, yeah, and yeah, this performs very well, and you do not need to rewrite your custom bash script to run this command again and again and again. Yeah, this proves my point. Let me give your feedbacks as much as possible. Okay, but I also if to improve myself. But yeah, how you want to define the environments? To define the environment, there are two options available. Either you can create a .env file here, and let's say .env file, call it port 5000, and okay, or you can define the environment different way, like or Okay. So there are two options available. My preferred options is not any kind of consistent. I like this both. It depends situation to situation. I don't have any preference. But yeah, this is my example to you guys. Let me know what you think about this video that I have created about the Docker, and what do you think. If you liked it or not, give me a thumbs up. Give me any kind of feedback to improve myself. Also, I will link out this app.eraser.io link to the comments to the description of the video. I will also leave the Git repository link as well in the description of the video. You can check it out. Please give your thumbs up or thumbs down if you like or dislike the video. Give me your comments or feedbacks. It's very important to improve myself. And yeah, and for this video, this is all it. And yeah, keep it up, guys. Let me and say goodbye. See you in another video. Bye.